Uh, Two of you emailed me asking about problem 3 on homework 9. I have not looked at the answer. It may be that the answer in the hints is wrong. I'm just going to solve it first, and we'll see if we agree. By the way, this sweatshirt is from my all-time favorite San Francisco restaurant at the corner of Kearny and Columbus. I hope it's still there. So we're going to assume these wires are infinitely long. That means we can use the Ampere's law result. For an infinite straight wire, we had 2 pi r b equals mu naught I. That gives us that b equals mu naught I over 2 pi r, and it is encircling the wire counterclockwise. So then, if I say, what is the force? You know, I actually think I should have drawn these 3 wires with different colors. You know what I'm going to do? I'm just going to draw these 3 letters with different colors. So I'm going to draw this A in magenta, and I'm going to draw this B in green, and I'm going to draw this C in blue. And then let's work out the force on wire B first, okay? So this is going to be, well, to do that, the first thing I want to do is I want to figure out the magnetic field at B due to this is going to be silly, but A and C. All right. So let's do the A term first here. All right. So the field due to A, it's gonna. And this is my right hand, even though it looks like a left hand. You can see the print on my shirt is backwards because the video is mirrored. So the current goes the way my right thumb goes. So that means the magnetic field encircles this way. So that means the magnetic field due to A at the position of B is going to be into the board. So I'm going to put a little into the board there. See, it would be out of the board over here. We don't actually care what's going on over here, but it would be out of the board over there. And then the magnetic field at B due to C is going to encircle the wire this way, so it's going to be out of the board here. So I think we're going to find that the magnetic force on B has to be 0. That kind of makes sense. So, you know, if you have 2 parallel wires carrying this, 2 parallel wires current in the same direction, they attract. And if they are in the opposite direction, they repel. So C by itself should try to push B toward A. A by itself should try to push B toward C. So I think we're going to find, well, I think actually we've already found. You see, the net magnetic field, because these are the same magnitude, because it's the same distance, it's the same current. It's going to be the same magnitude, but opposite direction. So you know the magnetic field is 0 at wire B. Let's write that out anyway, though. So the A term would be, and I'm going to make a coordinate system to make life a little easier. So let's call this the y-axis, and we'll call this the x-axis, and we'll call out of the board the z-axis. So then the force on, the magnetic field at B here. So this is mu naught I over 2 pi d is the distance, and then the magnetic field due to wire A at wire B is into the board, so that's minus k hat, and then we have a plus sign, and then we have mu naught I over 2 pi d, and then this is out of the board, so that's plus k hat. So there you go, that equals 0. So since the magnetic field is 0, and this wire is electrically neutral, you know, the charge carriers are moving, but it has the same number of electrons per unit length as positive ions, so there's no electrostatic force, and there's no magnetic field. So I would say, therefore, F on B equals 0. Okay. Then let's figure out the force on, well, let's figure out the field first. So then we can say, okay, the magnetic field at A, gee, I should write it. I think this is, maybe I'm going a little overboard with my color scheme, but let's say the magnetic field at A due to B and C, ouch, B and C, all right, that equals, all right, so the magnetic field at A due to B, so this is like that, so the magnetic field due to wire B is going to be into the board at A, so that's like into the board here, and it's going to be out of the board at C. Okay. Oh, by the way, the magnetic field due to A over at C is also going to be out of the board, but it'll be smaller than it was at B. And then the magnetic field due to C over at A is going to be out of the board. Okay, so this is out of the board. So that's out of the board. The one from B at A is into the board. The one from C at A is out of the board, but B is closer. All right, so the contribution at A due to B, this is going to be mu naught I over, this is a distance d apart, 2 pi d, and this is out of the board, so there's minus k hat, and then plus, and then we have due to C, so here's mu naught I over, now the distance from C to A is 2d, so that's going to be 4 pi d. I mean, you could call it 2 pi 2d, but that's 4 pi d. And then that is out of the board. So out of the board is plus k hat. Okay, so the result is going to be this magnitude into the board. So this is mu naught I over 4 pi d, because this is twice as big as this. This is out of the board, this is into the board, so it's going to be half the magnitude of this, and it's going to be out of the board, so minus k hat. Let's think if that makes sense. So at A, it's going to be out of the board because this one is closer. Yeah, so this is the presence of this one is just going to reduce the magnetic field here by a factor of 2. Okay, so that's the magnetic field. Now we want the force on A. So then we can say, and by the way, this is like a magnetic force. So the magnetic force on A is it's I L cross B. So actually the force per unit length, so we could say the force, so say per unit length, I don't know, per unit length. So that's like the force per unit length, how about that? On A. So now this is I L hat cross B. So that's I, what is L hat? Okay, for wire A, L hat is J hat. It's in the Y direction. So this is I J hat cross product with minus K hat mu naught I over 4 pi D. J cross K is I, so this is going to be in the minus I hat direction. So this seems like mu naught I squared minus I hat over 4 pi D. Let's see. Mu naught I squared over 4 pi D. There's a minus sign, J cross K is I. That looks good to me. I haven't checked the answer key yet. Let me do that. Aha! Now I see why so many of you wrote to me. I think the answer key just has the direction of the force wrong. So I don't see anything wrong with this. Let's just think about this. So we know that two parallel currents attract each other. So this left wire actually is repelled by the middle wire and it's attracted by this wire, but the repulsive force is stronger, so the force on the left wire should be to the left. And sure enough, the force on the left wire is to the left. So I think that's good. So I think the answer key just got all the signs backwards. So that's fine. Okay, now let's do the magnetic field at wire C due to, okay, so there's wire A and there's wire B. All right, and that equals, see, it's actually healthy for an answer key to be wrong once in a while because it builds your confidence in your own ability to, your own understanding. You say, no, that can't be right. Okay, so let's find the magnetic field at C due to wire A. That must be mu naught I over 4 pi D because it's 2D apart, so it's 2 pi times 2D is 4 pi D. And then the magnetic field at C due to B, due to A is in the minus K hat direction. Okay, let's make, so let's just double check that. The magnetic field at C due to A would be into the board, which is minus K hat. That's good. All right, and then we have the magnetic field at C due to B. So that is mu naught I over 2 pi D. And that is out of the board, so there's plus K hat. So this term is bigger. This term is half the size and it's in the opposite direction, so it basically just cuts this term in half. So that answer just equals mu naught I over 4 pi D in the plus K hat direction. And then we want to find the force per unit length. So we're going to need L hat again. Actually, it's the same thing. L hat is J hat for wire C here. So L hat equals J hat. Okay, so the force magnetic per unit length. This is like force per unit length. This is on wire C is I L hat cross B, which is I L hat is J hat cross, okay, B is in the plus K hat direction, and the coefficient is mu naught I over 4 pi D, and J cross K is I, so here is mu naught I squared over 4 pi D. J cross K is I, and this is in the plus I hat direction. Okay, so this is, you know, to the left. And this is to the right. All right. So sure enough, I think the signs were wrong in the answer key. So thank you for reaching out about that. I hope walking through the problem was helpful.